The reason we built this, so the circuit and a test is here. Okay. And we want to apply random tests, so random patterns, because we do not have a way to do test pattern generation and bring deterministic patterns. Okay, we are applying random patterns, and random patterns actually tend to detect quite a bit of faults. Okay. If random patterns are unable to detect all the faults, okay, so let us say random patterns give 80% coverage. For the remaining 20%, we may still need ATPG. See, this is a bad thing. Okay. So, we may never have a perfect based solution where it is fully self testable, right? Meaning it is fully capable of generating all the tests by itself. Okay. So, this is called as top up patterns. I may have mentioned to you that if I plot the number of faults covered or the fault coverage, okay, with the number of patterns, initially it will go up very sharply, but after that it tends to level off. Okay. So, we may get 80% coverage with the random patterns, and for the remaining 20%, unfortunately we may still have to rely on ATPG. Okay. So, rely on ATPG patterns for the remaining pattern, for the remaining faults. So, these patterns are called top up patterns. And the smaller the number of top up patterns, the better, because if I had to apply the top up patterns, I will need a test. But because the number of patterns is smaller, okay, maybe a lower cost tester will suffice. So, that is the advantage. But can we reduce the number of top up patterns? So, can we reduce the number of top up patterns? The answer to that question is yes, right. We can try and reduce. Careful design of the cut, how to reduce top up patterns. So, we may have to insert what are called as test points. Right. So, we have discussed this before, right. So, if I have a circuit and a test, some points or some faults are hard to test because they have poor controllability or poor observability. or both. Okay. So, let us say there is a gate here which is an 8 input AND gate. So, if I am looking for a stuck at 0 fault here, in order to activate the fault I have to put a 1. Okay. So, put 1 to activate the fault. But if a random pattern is trying to put a 1 on the output of the gate, it is not going to be easy, because all the inputs have to become 1. Okay. When you do random pattern generation, the chance that all the 8 inputs of the AND gate will become 1 is somewhat low, right. So, that is the reason why it is this fault is random pattern resistant. It resists being detected by a random fault. So, inserting some test points will help. Okay. For example, if I now redesign this circuit, there is an 8 input AND gate, but here let us say I have an OR gate that I have introduced. Okay. So, this is a test input. Okay. Under normal operation, I will make test control equal to 0. Okay. So, as a result, the functionality has not changed. Okay. The output of the AND gate is being ORed with 0, and as a result the output here has the same functionality as the output at the gate. Okay. So, there is no change between these 2 points, but in the test mode I can control this to 1, and as a result I can directly send a 1 here. Okay. So, that is a way of improving the test the 1 controllability. Okay. In the same way, 0 controllability can be improved by adding a AND gate. Okay. Similarly, if I am worried about the observability here, I can try to bring that pin as an output pin. Normally, it is not required to observe that line, but we can add an extra pin to observe that particular wire. Okay. So, we can improve the controllability and observability of the internal points. That will improve the testability, and that would reduce the number of top-up patterns. Okay. We can reduce the number of top-up patterns because now random patterns are able to detect. Okay. Okay. So, that is the main advantage of test point insertion. So, with the when we increase we can possibly make this 80% to maybe 90% with insertion of test points. Okay. Then the only 10% of the faults will have to be covered using ATPG. Okay. So, today there are many tools which do that. So, any logic BIS tool will insert test points, and if you allow it to insert more test points, then it will be able to reduce the number of top-up patterns. It will do it better and better.